Okay, so let's talk about normals. This is the second part in tangents and normals, the first subtopic for application of differentiation. So normal is very easy as it's a line reciprocal towards tangent line. Okay, so the most important word over here is reciprocal, meaning if we have this is your tangent line and this is going to be your normal line, and we have learned before that the relationship between a normal line and a tangent line, or a reciprocal lines in a sense, is going to be the multiplication of their gradient or slope value will always be -1. So the most important part in this section is simply knowing that your mn multiplied with your mt is equal to -1. Sorry about that. So if you know how to find your mt, then you can simply extend your working to find your mn. So let's take a look at this example 2. The first, the only example for our normal part. Alright. Looking at the question, you are given again a function which is a y, but it's a little bit tricky where it says that it's going to meet the line x equivalent to 4. So there's a little bit of lacking information over here, as you know that you need both x and y, but you are only given x. So do not fret, because you can simply find your y later that can be used for deriving your equation of normal line. Thus, let's proceed as usual over here. Firstly, you are given with y equivalent to x squared plus 5x minus 2. Now, we're going to take it a little bit simple, because you already know that the dy dx is the gradient of the tangent lines function. So this is going to be 2x plus 5, a very simple one. And to find the slope for the tangent line, it's given that this one is at x equal to 4, only missing y value. So we can substitute the 4 over here and get the value for mt. So this is the slope for the tangent line. So we are interested in the gradient or the slope, or you can use the slope word over here, of normal. So this is the new thing that we have now. So mn multiply with mt is equivalent to -1. So you can say that mn is equivalent to -1 divided by mt. So it's going to be not so beautiful, 1/13 and a negative over there. Now, since we are missing the y value, so you can find the y value at x equal to 4. So always remember, a function which is a y is dependent on the x value. So if you know what is the y represented in x, or function of x, and you are given any x value, then your y can be easily found by using these two informations. So we have 5 multiplied with a 4 minus 2. So this one is a 34. Alright, now that you have mn, you have xt and xn, it will be your enough for us to find our equation of a normal line. So equation normal line is going to be y minus, we just simply need to change the t to n. Okay, so I'm not writing t instead. Okay, Right, so y minus y n mn x minus xn. Okay, so this is the proper one. Where is our y? Y is 34 and mn is a negative 1 over 13. X minus 4. A lot of big values over here. You can rewrite your answer as before, y equal to whatever x value and c, ymx plus c. And also you can write your answer in general form like this: 13y plus x minus 446 equals 0. So that is the equation of the normal that we are looking for.